All right, let's get into it. We've all played around with chatbots, right? But today, we're going way beyond that. We're going to look under the hood at how you build the really advanced AI agents. The ones that can actually manage complex, real-world tasks.
So this is the big question for anyone serious about building with AI. How do you make something that doesn't just talk, but can actually do things for you? Something that can tackle a multi-step project, use different tools, and actually see it all the way through to the end. That's the real challenge we're going to unpack.
And the answer, really, is to move past those simple chatbots and into this whole other world of what we call stateful agents. This is, without a doubt, the next big leap for AI applications. So what does stateful even mean? Well, it's all about two things: memory and action. This isn't just a fun little chatbot you talk to. It's a system that's literally designed to handle a sequence of tasks, to go out and use other tools like a booking API, make decisions as it goes, and, this is the crucial part, remember the entire conversation and context from start to finish.
Okay, but here's the catch. When you try to build one of these powerful agents, you immediately run into this huge wall in the tech world. It's this conflict between the language of AI and the language of the web.
And here's the problem in a nutshell. All the best, most powerful, most mature libraries for making AI agents think and act, they're all in Python. But all the slick, modern, interactive websites and apps that you and I love to use, those are all built with JavaScript. So you've got this major language barrier running right through the middle of your project. I mean, look at this. On one side, you've got Python, with decades of academic research behind it, giving it this incredibly deep AI ecosystem. And on the other side, you have JavaScript, the absolute powerhouse of the modern web, totally built for speed and amazing user interfaces. You need the best of both worlds, but they don't speak the same language.
So what do? Well, you don't pick one and sacrifice the other. No way. You build a bridge, an architectural bridge. And this whole approach is what's known as the dual-stack solution.
On one side of that bridge, you have the AI brain, and this is built using a Python framework called LangGraph. You should really think of this as the agent's central nervous system. It handles all the heavy lifting, the complex logic, figuring out what task comes next, and most importantly, keeping track of the agent's memory, or its state. Then, on the other side of the bridge, you've got the public face. This is built with something like Next.js, a super popular JavaScript framework. This is everything the user actually sees and touches: the chat window, the buttons, the cool animations. Its entire job is to create a beautiful, seamless experience for the user. But how do the brain and the face actually talk to each other? That's where our universal translator comes in. We use a high-performance Python tool called FastAPI. It creates this API layer that sits right in the middle, acting as the go-between. It translates requests from the JavaScript front-end into actions for the Python brain, and then sends the results right back.
So let's just break this down real quick. You've got LangGraph in Python doing all the heavy AI thinking. You have Next.js in JavaScript making everything look good and feel interactive. And smack in the middle is FastAPI, also in Python, acting as that crucial gateway so they can both work together in perfect harmony. Each piece has its own very specific job.
Now, the real secret sauce here, the thing that makes this whole bridge work, is a shared language. It's this special little data packet called an app checkpoint. Just think of it like a perfect snapshot, a blueprint of the agent's current state, what it remembers, what step it's on, everything. It's structured in a way that both the Python brain and the JavaScript body can read it and know exactly what's going on. It is the Rosetta Stone for this entire architecture. So right about now, you're probably thinking, wow, this sounds complicated. And you're right, it is. But here's the thing. This complexity pays off in a huge way. It unlocks some incredible superpowers for your agent that are just almost impossible to get any other way. Okay, superpower number 1, guaranteed persistence. Every single time the agent takes a step, LangGraph automatically saves its entire memory as one of those checkpoints we talked about. This is a game changer. It means if your server goes down or you have to restart something, the conversation can pick up exactly where it left off, flawlessly. It also lets you do cool stuff like rewind a conversation and try a different path, kind of like a choose-your-own-adventure for AI.
The second superpower is maybe even more important, especially when the agent is doing things with real-world consequences. It's called human-in-the-loop, or HITL for short.
Let me walk you through how it works. So, imagine your AI agent is about to do something big, like book a non-refundable plane ticket. Instead of just going for it, it automatically pauses. Then, the user interface pops up a really clear question.
Are you sure you want to book this? You, the human, click Confirm, and only after it gets your OK does the agent resume its task, picking up from that exact spot. This is absolutely crucial for building trust and safety.
So all of this brings us to what I like to call the Great Stack Showdown. Because choosing to build this way, with this dual stack architecture, it's not just a technical choice, it's a major strategic decision, and it comes with some serious trade-offs.
And here's the core trade-off, right here. The dual stack approach we've been talking about with Python and JavaScript, that's all about prioritizing maximum power, maximum capability, and total control. The other option, a unified stack built only in JavaScript, is all about prioritizing simplicity and getting to deployment faster.
This chart really lays it all out. With the dual stack, you get the absolute highest level of agent sophistication. Things like persistence and human in the loop are just baked right in. The downside? It's more complex to deploy. You might need 2 separate dev teams. The all JavaScript stack is way simpler to get up and running, but you're going to have to custom build all those advanced state features yourself.
And that leads us to the final question, really. How do you choose your AI future? What does this all mean for what comes next?
Well, the consensus from the people building these things is pretty clear. Right now, for the most demanding, mission-critical AI agents, the ones that need to be incredibly reliable and have advanced controls, this dual-stack architecture is the definitive choice. You're basically deciding that the extra operational complexity is a price worth paying for superior AI capability.
And that kind of leaves us with this final thought to chew on. As AI just keeps getting more and more powerful, we're going to keep facing this choice between the easy path and the most capable path. So, is the future going to be built on whatever's simplest to deploy? Or are we going to keep building these complex, powerful bridges to harness the best tools we have, no matter how hard it is? That's a question that every single developer in the space is going to have to answer.